I hope by this time you have a better understanding of different type of load balancers available in AWS. We will focus on application load balancer. For this particular demo, I have divided this into 4 specific steps. Step 1, we would deploy a VPC. Then we will deploy some web server in private subnets of the VPC. Afterward, we would deploy a load balancer and see how it works in the step 4. So these are the 4 steps I will go through. I would focus first on step number 1, which is deploy a VPC. I am trying to build this architecture. I want to use a region, a VPC, with minimum of 2 availability zones. Subnets in each availability zone, one I want to use as a public, another as private, and a NAT gateway so my internal machine can initiate a communication to external world if the need be. Like maybe I have to install something or deploy something on those internal machine, I would then leverage NAT gateway. To get started, I would use the wizard which is there in a VPC creation process. So I am on my console home in Northern Virginia region. I am selecting VPC as a service to set up the infrastructure of networking first, and here I could create all of these things one by one like subnet and then route table and then NAT gateway and all. Rather than that, I am going to focus on a wizard driven process which I can select here called VPC and more. So when I say this, what is going to happen that I would get a lot of things automatically created for me following some of the best practices. I still have control on it, like I could change the name of it. So I would have a project VPC created. In that project VPC, we would have subnets created. In 1A availability zone, there will be 2 subnet, one public, one private. In 1B availability zone, we would have one public, one private, and my project subnet public one has a route table entry for RTB public, which allows me to go to internet, and then these these subnet have specific route table associated. We'll see that. And you can customize all these things. I'm going with the default to keep things simple. I'm using the same CIDR range. I do not need IPv6. I'm okay with 2 availability zones. You could be selective here. Number of public subnet 2, private 2 is fine. I just need a NAT gateway. So yes, one in 1AZ, I am selecting that. I am not requiring any of the VPC endpoint communication, so I would say I don't need it. Once I'm happy with that, I would go ahead and say create a VPC. So this process has started all the component creation one after the other, and it will make my life much easier because I do not have to configure and individually create those things. Now it may take little time because a NAT gateway is getting created, elastic IP is associated, then a NAT gateway spin up, and then its entry would be added into the routing table. So I hope everyone is following along and understanding what I have just initiated. So what I would end up with, I would end up with this architecture, and in my step 2, then we will deploy web servers. So I'll pause video for a while, let it finish, and I'll come back and we will then start deploying web servers. Alright, so you could see the whole process has finished and I got my VPC available. Let me go ahead and quickly check that. This is my VPC, which is project VPC, and now I would focus on creating EC2 instances. So let me navigate to EC2. Now, I would deploy a standard web server, but I would push a specific user data script in that EC2 instance so that it will become a web server and it will display me some information on a web page so that I can know from where the request is answered, which availability zone and which IP address is answering me. So we'll see that in a minute. So I'm launching an instance. That is a pretty standard process of launching an instance. So I'm going through that. I would call it web1, just web server 1, which I'm deploying. I would be selecting different Amazon machine images. Now, intentionally, I am not selecting 2023 AMI because this one has instance metadata, which only we call version 2 of instance metadata. I am not using that, and that's why I want to still stick to the old method of instance metadata, and that's why I'm using Linux 2 AMI. Right. Once I have selected that, I would select the architecture of that, which instance type T2 micro is fine. Key pair, I do not need it, so I would skip that. Network setting, this is where I have to make changes, and my intention is to get this machine spin up into a private subnet. So I selected a project VPC, and I have selected here 1A private subnet. So this will end up into US East 1A first availability zone, auto assign public IP disabled. I would need a security group. So let me create a web security group here so that I could access it over a HTTP protocol. I would just pass on the same information about the description. What I want to allow. I am not interested in SSS, so I would remove that rule. I am interested to allow HTTP traffic. Now, what I'm doing here is not something you would do in production. I'm just showing a demo, and that's why I had just kept a broad range of request available. Like I'm saying here, allow port number 80 from anywhere, and that's all I'm doing. In real life, what you would be doing, you would be ensuring that you are only allowing traffic from the load balancers. So you could have a different security group for load balancer and allow traffic only from those load balancer security group to come to your EC2 instances. Right now I am just using one security group for everything to keep things simple. Once I'm happy with that, I would have some configuration information about storage, some advanced detail. This is what I'm interested in. I am interested in selecting a configuration of user data. Hope you remember user data. This is a way of customizing the deployment behavior of EC2 or the operating system changes when it is deploying it. So that's what we want to include. What I plan to include here, I want to push a simple script which would make this as a web server and which would allow me to have a web page created. So simple script, I'm updating this particular web service, yum install HTTPD, keeping it ready. Then I'm saying I want to have a web page created called index.html. I would be displaying the IP address as a body, and then I would say please get data from this IP address. This is the instance metadata IP address. So internally, if you want to access information about the instance, like which IP it is connected to, or which availability zone it is part of, which AMI it is spin up from, all this information can be queried from this particular IP address, which is called your instance metadata. So I'm querying that particular information, and I'm just gathering the local IP4 information, which will be local IP address, and appending it to index.html. So it will display me the IP address and the actual local IP address of the instance in a dynamic fashion. Then I am saying I am looking for availability zone information also, and same metadata can display to me availability zone information. I am appending that also into index.html, and that is how I have created an index.html file which would show me the IP address of the instance and the availability zone it belongs to. So this is the basic information. I would copy this and push it to the user data section here. Right. I would make this script available into the resources section, so you should be able to get hand on that. Summary, I am keeping one instance only, and I say launch instance. I am happy with what I have done so far for first instance. Let me keep on launching another instance also, and then we'll see how it looks. So this is W1 getting started. Let me also go to W2, and we would use the same setting, but intentionally we will keep it into a different availability zone so that we can see how load balancer would forward traffic to it. I'm selecting Amazon Linux to AMI here, same thing which I did previously. Then I would be selecting key pair, not required, proceed without key pair. Network setting, yes, I need to modify here. I would select project VPC. If you remember, we selected first one to private 1A. This one, I would be keeping it into private 1B, which is US East 1B. So this is the second location where my instance would be getting deployed. Other setting about security group, I am keeping the same security group available here. So I would use WebSG here, and same user data information I would pass on in advanced detail so that my instance would have the same information available as a web page, but obviously this IP address and availability zone would be different. Now these instances are in private subnet, so I can't access them directly right now, but we would deploy a load balancer and then we'll see how we access it. So what we achieved so far, we have achieved deployment of VPC. We have deployed web servers like this, and now step 3, which I am looking for, is to deploy a application load balancer. Now application load balancer is in the graphical console, you will find it within the EC2 section. So I'm on EC2 section, and here I would be finding load balancers. Pretty intuitive wizard driven process. I do not have any load balancer at all as of now. That's completely fine. Let me start by creating a load balancer. So here it displays to me what type of load balancer I am looking for. Is it going to be application which will receive traffic on HTTP and HTTPS and forward this to different targets? Same thing here. I would have a network load balancer maybe which would accept TCP, UDP and TLS traffic, and then gateway load balancer also. You could deploy that. Now, classic load balancer is still existing in the console, but it is kind of hidden away in the plain sight. So I would select my application load balancer. As of now, I would go with the create process. It would ask me some question, ALB name. So I would give it a simple name, ALB01. Then I could decide whether it is going to be internet facing load balancer or an internal load balancer. What we mean by this, let me explain that thing. Now, consider that you have a three-tier app. There is a web tier, there is an app tier, and there is a database tier. Right? Web, app, and databases. Now, if I'm deploying my web servers here, let me draw them. Let's say these are my EC2 instances, and then app server is made up of EC2 instances, and then maybe RDS database for my database tier. What I would be doing, I would be ensuring that I deploy a load balancer which would have front end into public subnet so that public can access it, means it can receive traffic from internet, and then it will forward traffic to these web servers which are into my private subnet. So this one is my internet facing load balancer. On the other hand, when web server wants to talk to app server, what I could do, I could also deploy one more component here. So I could have deployed a component here, and that component, which is I'm saying load balancer, this elastic load balancer here would be receiving traffic from private subnet, forwarding it to private, and that's why we would be calling this as your internal load balancer. So you decide what you want. Right now we are focusing here. So we will deploy a public facing load balancer in this case. I hope this thing is clear. So let's go back to console. I would keep internet facing. I'm okay with only IPv4 addresses. I do not need IPv6 maybe now. Network mapping, this is important. At which specific location my network load balancer would be deployed. So it would exist within a VPC. So I have to select that. And I could then say from which subnet it would receive and forward traffic to. So this subnet which I am selecting, or what we call mapping, these are the mapping of the load balancer itself. So I'm saying I would use 1A and 1B. Why only these two? Because I have subnets created only on these two availability zone. That's why they are being highlighted. And when you are doing this thing, make sure you select the right subnet. So I selected public one. In 1A, I do not see any warning, and if I selected like private, I would be getting a warning which says the selected subnet does not have a route to an internet gateway. This is a private subnet and it may not work well based on the configuration I selected, because I selected I want an internet facing load balancer. So that would require a subnet which has a route to internet gateway. I would keep it here. So this is my first subnet, and I'm selecting 1B also. You could be going away with one only, but we want to create a highly available architecture. So both public subnet is where my load balancer would be deployed, assigned by AWS, which are the IP addresses that will automatically come. And obviously, if it is a network component, it would be protected by a security group. I could use a new security group for it, but to keep things simple, I am using same WebSG as of now. Right. Next thing is listener. Listener is someone who would accept traffic or listen for a traffic. It's like ears of load balancer. It would listen to a request coming on port number 80 like this, or I could have created more listener on it, should not be a problem. So listener is the traffic interceptor in a way who would receive traffic on port number 80. Now it is not a storage location. It is not storing any data. As soon as a request comes to load balancer, it forwards request to the target, which we will be discussing in a minute. So it is not storing any information, it is just a forwarder. So second question comes, okay, if you want to receive traffic on port 80, where you want to forward it, what is your target group? Target group is a logical group of resources which would respond when the request comes. This target group you could create, which can be made up of instances or which could be made up of IP addresses. Even those IP can be on-prem resources. The target group can be of Lambda function. Target group can be an application load balancer itself, means a new load balancer which may be receiving traffic from this particular load balance. So you could decide on that. Now, one thing to be aware that you cannot mix and match different targets inside a target group. So if I'm creating a target group for instances, only instances can be part of it. If I'm creating a target group of Lambda functions, only Lambda functions can be part of it. So it is a homogeneous type of member who can be in a target group. I selected instances as my target group, and I would give it a name web server target group. Now, I am here keeping same port number 80, but in your real life, based on your application need, you may have a different port number where your application would respond to, so that is completely fine. And now I am saying which VPC I want to be incorporated with. So it is a project VPC, which protocol version I want to use, 1 or 2 or gRPC, it is up to me, and I can perform health check on my systems. Health check is like we can think like a heartbeat of a person who tells whether it is working fine or whether the heart is functioning fine or not. Similarly, for my servers, I may want to have a health check configured, and this health check would tell me whether this particular instance or Lambda function is in a place to receive request and respond to that or not. That is the function of a health check. You could configure health check for HTTP or HTTPS. I would prefer to use index.html, which we created on those web server, to be checked, and if it responds with a code 200, we would consider everything is fine, which is HTTP OK code. But if any other code comes back as a response, we would say there is some issue, and we may declare that particular instance as unhealthy. So load balancer won't forward traffic to unhealthy instances. So we need to ensure that whatever health check we are configuring is there on the instance and it responds. We could configure some setting like port number, any threshold for it. I am keeping its number lesser based on, so that we can get results faster. But depending on your use case, depending on your application requirement, you would be keeping a different interval and timeout setting associated with it. And I'm expecting as a response a 200 code, but you could have used a different code also. Even you could use range for a specific type of application. So that is possible. Any additional attribute, I don't want them. Tags, I don't want to use it. So that's what I have created. I created a target group. So we were on the process of creating a load balancer. If I look at this tab, we were creating a load balancer, but it asked me to use a target group, and that's what we did here. We created a target group based on the settings we have configured, and once we finish this, we would go back to load balancer wizard. Now next is, it is just the logical setting, right? Who is actually going to be the part of this target group? So here I have these instances who can be part of my target group. I could select both instances, W1 and W2. They are running fine. This is their instance health check. It has nothing to do with load balancer health check as of now, but I could go ahead and say I want to include these two as targets for my target group. So both of them are added. Their health status is pending because there is some time we configured. It will verify within that time frame that many times of interval if a request is responded or not. And once I am done with that, I would say create target group. So my target group is ready. Once this is ready, I could use this target group in my load balancer, if you see. So I could now refresh here and my target group is displayed. I can go ahead and then move forward. Now, A load balancer can have multiple listeners, like I have one listener for HTTP. If I want, I could have added another listener here, and which may be, let's say, for HTTPS particular protocol, which is 443. And that may be forwarding request to the same target group or maybe to a different target group. So one single load balancer can have multiple listener associated and can have multiple target groups behind it, and forward traffic to them shouldn't be a problem. I'm not interested in HTTPS as of now, so I would remove that. I would just keep HTTP 80. Any additional services, something like Web Application Firewall, Global Accelerator, AWS Config, all these integration can also happen, but I'm not interested in right now. I would just go ahead and check the quickly summary, and if everything is fine, we would click on deploy my load balancer. So we are deploying a ALB01 with this security group. It is having 1A and 1B availability zone subnet with associated with that, listening on port number 80 and forwarding traffic to web server target group. That's all, and I can say create a load balancer. So what is happening behind the scene, that we are getting a load balancer deployed like this. The subnet we selected, they would become like a connection to the load balancer. Load balancer itself is a managed service. So though we see it as one being deployed for us, but technically behind the scene, what AWS is doing, they are deploying load balancers like this. So even if one of the availability zone completely goes down, my request will still be fulfilled by other availability zones, shouldn't be a problem. So that is what will be happening when my load balancer is getting ready. So we are on the process of deploying the load balancer. This application load balancer is spinning up, and what it would get a DNS name. Right, so we will be getting a DNS name. I'll show you that in a minute, and then probably you would use that DNS name to be mapped to a application name or a friendly name which your users can remember. So my load balancer is going through the creation process. Let me go ahead and see what is happening with that particular process. So we are searching for ALB01, and it can be seen is in provisioning state across to availability zone, and this is the DNS name which has been assigned by AWS to me, ALB01, a random number, US East 1, ELB Amazon AWS.com. Right. If you want to see details, here are some more details associated with that, like internet facing or not, which subnet, what is the hosted zone on that. Then we have listener confirmation information. I could go ahead and modify that listener later also, shouldn't be a problem at all. So that is completely acceptable and configurable. Plus network mapping, which network it is connected to. So this is my mapping, and these are the things we are connected to. We got one IP address from 10.0 series, another from 10.0.16 series. We have seen, we will be getting that. Security group, that can be also modified. CloudWatch will also be there, so that you should be able to see some basic information about the load balancer, like number of requests coming in, what was the response time associated, any HTTP 500 series errors, 400 series error. So those type of things should be displayed to you. Plus it can be integrated with other services like Route 53 application recovery, Global Accelerator, Config, WAF. These all integration points are also possible, and maybe some additional attributes which you could configure, like TLS setting, WAF, ideal timeout setting on that. Plus you could have also configured some tags to easily identify it. So I hope you are getting the idea. It's very easy to get started, and as it is a managed service, all the performance and then update patching would all be maintained by AWS. I don't have to worry about it. Now once this finishes and goes into active state, we would start sending requests to it. It is in active state, and let me now go ahead and check this load balancer by connecting it on a browser. Now this is the domain name I am connecting to. I am deploying an application load balancer, so it doesn't give me a IP address, but I get a domain name which I would map to my user friendly name for my own application. And now I am coming here. So my request is being received. And what I get here is a web page which is obviously not coming from the load balancer itself, but this is coming from an instance which is having IP address 10.0.129.21 and its availability zone is 1A. So that instance has responded to me if I start talking to load balancer. This is first user. Let me refresh it, simulating another request coming in, and let's see what happens. I refreshed it, same 21. Right now I refreshed it and now my request has gone to 215, which is a second instance in a different availability zone. So if I keep on refreshing, my request is in round robin fashion being responded by different instances behind the scene. I had only two. If I had 100, it would again be round robin fashion displayed from these 100 instances. So I hope you have idea now what is actually happening. So when I am sending a request, those requests through internet gateway land to application load balancer, and then it forward those requests to web server 1 in one availability zone, web server 2, and for subsequent request also it would keep on following the same process. So I hope you have a better idea on how application load balancer is deployed. So pretty simple demo. You could also try it on your own. Won't take more than 10-15 minutes for you to try on, and I would include this script into the resources section, so you can also use the same script or be creative and add more information if you want to. That is completely possible. And I have also included what is a listener, what is a target group, and what is a health check, some information for further reading. So I hope you enjoyed and learned something about target groups, listener, health check, and we deployed a application load balancer. In next module, we will discuss more interesting stuff. Okay, thank you.